Okay, so next subtopic is analytical versus numerical solutions, and obviously, numerical methods going to be an important part of this subtopic since right in our title of our module. And then, of course, the first thing we can do is talk about what numerical methods even is. And in doing this, I think that the point is that's well illustrated by a simple analogy. And it goes something like this. You have a mathematician and then, of course, an engineer. So there's a contest of shooting the ball where the mathematician is being very careful and computing on how to shoot it ringless, right? But the engineer is showing that you don't need to shoot it perfectly. All you need is just to shoot it. That's it. You don't need to calculate into an exact way. You just only need is to approximate. And so the engineers wins, of course, because the mathematician never estimates. And so you have a lot of math classes already. And what we have here in our numerical methods is a situation where, on the one hand, we have a numerical methods. Okay, and numerical methods are sort of engineer methods. They are approximate. They're not exact. And we get the wrong answer. And we know it. Okay, but it is, well, it is the wrong answer. And we realize that if we use a good numerical method, we know that we're not by very far. And we'll get into on exactly how we figure out how far we offer, how far off we. And if we're okay with that and everything else but numerical methods then are set up as opposed to approximate methods, no, that's kidding, or that's not true. Not actually an approximate methods. It's actually a numerical methods. Okay? So, numerical methods are set up in opposition to analytical methods. Okay, analytical methods exact. And then, of course, the numerical methods are approximate. Now, you might not realize it, but you actually no stranger to analytical methods. In fact, many of the courses that you've been taking, which is all of your math courses, are setting you up, teaching you analytical methods, right? For solving math problems. So, for example, we have algebra. I hope you all took algebras. Again, it's a prerequisite for this course. So we have a calculus, right? Linear algebra, and even of course your subject before, which is a differential equation before numerical methods for engineers, which is our subject. It's also of course a prerequisite for this course. And of course we have both ordinary and partial differentiation equations. Similarly for numerical methods. In this that we're going to have in this course is numerical methods, and we actually end up covering a lot of the same topics for your algebra. We're going to do things like root finding, right? Finding x, right? Which was one of those topics that we had in algebra. In linear algebra, we have the equation, like for example, b is equal to ax, or depending on how they taught it to you, or ax equals to b, same thing, two different ways of thinking about it. And we learn it about all different ways that we could solve that equation, but in approximate way, not necessarily requiring you to have, of course, an exact answer. And then we also have calculus, a concepts in calculus you may remember doing integration, right? Integration, differentiation also. We have also an optimization. You may remember doing integration, right? Integration, optimization, and probably did a fair amount of optimization. So these are those topics that we're also going to cover in this course. We're also going to cover numerical methods for solving differential equation. So keep in mind as we go through this course that these methods are going to run parallel, the analytical methods. Yes, parallel to the numerical methods. And so it's important whenever you learn anything new to make, of course, these connections with the prior knowledge that you have. And so we learn about all those different things into a numerical methods also. So don't forget about the analytical methods that you've spent so much time learning. But draw comparison and we can contrast and compare how we are doing things and how they are similar to the other ways we do things. And we're often going to be reminding you guys of the ways that you learn for solving the different methods analytically. And then let's compare into a numerical approach to that.